Yes.
We're good?
Great. Hi guys. I don't think anyone is watching this right now because it just went live. But those of you who are just joining in,
No one is in yet.
no one's here.
So it's one view. That's me.
No, that's okay.
That's okay.
But the
Alright.
thing is, it's
Start sharing.
yeah, we. So I want to say everybody in this late afternoon.
Let's share.
Alright.
Let us share the groups.
We have an actual viewer.
Okay, we have an actual viewer.
We
Okay.
have a viewer.
Listen, you're the first viewer. We're just
First
going
viewer.
live from San Francisco, and thank you for joining. Love it.
It was to me.
It was.
Oh my god.
Woo! Okay, listen. Do not once we're live, we are live. We can just save it. Okay, so okay, yeah. We want to start this. So we want to talk about. So today we're live from San Francisco from Archie.AI headquarters. This is actually a garage. So we're talking about bots and conversations. And I think lately you guys have a lot, since this is posted on Facebook, you've definitely heard of bots. And this broadcast is actually going out live in certain specific groups that are known for bots. So this is something that we all actually think about. Bots and conversations. Doesn't matter how weird that sounds. But here with me, I have Adriano Hernandez, who is an engineer at Archie.AI, and I'm Rahman, and we're going to talk about bots and conversations. Now, Adriano today has some solutions about how we can actually have conversations incorporated into for bots. But before we do that, I want to do this little quick thing, this joke that we do with our third little anchor over here. It's Google Home here. Okay, Google, get me Archie Voice.
Sure, here's the test version of Archie Voice.
Archie here, I am ready.
Archie, tell me a joke.
Here's one. Alexa, Google, and Siri walk into a bar and none of them had a conversation. What else do you need?
Nothing. So
Fine.
So you see the joke, it's notoriously difficult for bots to actually have conversations, and we're actually going to break down what that actually means. What is a conversation? So Adriano, tell me, what is a conversation? How do you define a conversation than just a question and answer?
So a conversation is a set of questions and answers, but where context is preserved. So I might ask you something and you might respond, and then we might talk about something else, and then I might go back to the original thing, but we'll remember it, right? Which is important, because that means that we don't have to it's not one stage, but there's a lot of layers to it.
Right. So you just focused on the timing sense. So if we're talking about right now, we know we're talking about bots.
Exactly.
But there can be other kind of context, right? So for example, you walk into office in the morning, I already know that we are talking about Archie, right? And I say, how many people, how many users? And you give me a number because you already know because of the context. This might be the first thing we talk about in the morning.
Yeah.
So what other variables are there for context?
Of course, there's where you are, right? So who you're with is very important.
Who you're with?
Yeah, who you're with,
Okay.
what time.
What time?
It also matters, I guess if you can tell, the tone of people or other more nuanced things, which is difficult for bots, but if you can tell that,
Right.
you might know if they are trying to get at something that they're not saying explicitly.
Right.
So there's a lot more layers than just the words being said
Right. So
during a conversation.
So what it turns out is that in every conversations, there could be multiple variables that define what this undefined is. So for example, in our particular example with the Archie.AI artificial intelligence, a lot of our customers or a lot of our users just ask, hey, Archie, what was my traffic in the last 30 days? And Archie responds, hey, your traffic was blah, and then say, what about in the last 7 days? And then it is difficult for us to understand what is he talking about. And now, in this case, what are some of the solutions that you can talk about?
So I guess we can put them here. So
Sure.
we have a couple. We came up with 3 solutions. So one which is very naive, and one which is okay, and one which is probably the best. But a very naive solution would be, because we're using a classifier right now, which basically means that where we have like examples of questions, and we have also the proper intent that's being asked from that question, and we tell the bot to learn what intent to match with what question, and from that we can figure out the intent at every one question given by the user. So a very naive approach that we could do, which would probably we would be able to implement very quickly using our current architecture, would basically be to create a new intent, where it would basically be to remember the previous thing that was said. So we would store somewhere previous data, and then there would be an intent that might be to figure out what was said 1 or 2 questions back. So that would be a very naive approach, and it would be very fishy, and it wouldn't work too well. So a better approach, which we could do, we could create like a conversation tree, and we could use our classifier at each step. So we might have we might start here, right? And then we would classify, and then we would figure out what they want, and it could branch depending on what you want to talk about, right? And at each step, you can use the classifier to bring the right answer, and it would remember what was said in a previous branch. So in this way, you can traverse up and down to get the data that you want that's relevant to the current question, if it's a context question. Right. So you could do that.
Okay.
And that's a much better solution. And we could have different trees for different types of conversations, but it's a little bit difficult once it gets very large, because we're basically coding a lot of this by hand if we're making a tree, and it's a little bit inflexible.
Mm-hmm.
So it's good because we already have some of this tree structure for an open source API we have, which is Bubbles.
So this is a decision tree. This is the
basically.
classic decision tree solution, where I think this is good for when you know exactly what you want your users to do, right? Which could be great in a scenario where your variables don't, there are not a lot of different kind of variables, right? How about a solution? So that's your number one.
So that's one other solution we have, but
so talk to me a little bit about the pros and cons of it, of this.
Yeah. So basically, the cons are that it's not flexible.
Not flexible. Yes.
And that it's a little bit tedious once it gets large, so it might not be very scalable.
Mm-hmm.
It's good because we don't need that much training data, which we need for some solutions that we're going to talk about shortly.
Right.
So yeah, it's basically like a quick fix, but eventually we might want to do something else.
You're right.
So another solution which we could do.
So that is available on GitHub. If you want to check out our open source bot solution, we have it on GitHub. Our CTO Dimitri Cherbaji wrote this, and we are continuously submitting new updates to it. Interesting enough, our Jeopardy is also on that. So continue on the next one.
So the other idea we had was that we could use a recurrent net, and we could basically store information, and we could train the net to, from the previous information, figure out what to get.
So slow it down. What is a recurring net?
So for a regular net, right? You might have your input layer. So you have 3. Let's just draw a really simple one.
layer, okay.
So this is your output layer, and this is your hidden layer.
Hidden layer in the middle, okay.
Something like this.
Right. These relationships that adjust to solve for the inputs.
But there are times when you need to know different states of something. So say you're looking at a video and you want to know if a tennis player is going to hit a ball. You can't just look at that one frame, because the ball could be going in any different direction. So you need all the previous frames. The sequence matters.
Sequence does matter when sequence matters.
Yeah, so basically for for recurrent net, you'll have the other states, and you'll have them tied into these. So what you have is I should have brought an eraser. But you'll have this would be in, out for your net. And then you might have I don't know, a hyperbolic tangent activation, and it might go like this.
Okay.
But you would also tie in the thing you got from the previous state.
Right.
And so on and so forth. So this way it's kind of like a little chain, and it remembers the history. So in this way we store information from the previous conversation, and we also are able to train it to figure out out because it's obviously taking into account previous data.
Right.
The one,
And this is important because in conversations, context is important.
Yes.
You want to know,
and
and
this is where context is.
yeah, this is where the context is on the same layer, right?
Yeah.
Okay.
So this is a simple implementation,
Okay.
but the problem with this is that I won't remember stuff from very long ago. If we have like 20 of these, it's going to get really bad.
And
because-
processing would be very cumbersome.
Because what you can see here is that because you're passing it into the hyperbolic tangent in this example, everything is like the outputs are getting normalized between -1 and 1. So that means that it's getting like crushed a little bit. So it gets crushed every single time, and if it goes from really far back, it loses a lot of its weight. So it doesn't really affect the current state very much. So a better solution is like a long short-term memory
Right.
net, which is basically a slightly better version of this, where it will also, yeah, I'll redraw it just to
Right.
to fit some new stuff. So we'll have these things again, right? And we'll have our hyperbolic tangent, and it'll take the stuff from the previous one.
Mhm.
But also, we will remember like something here in a straight line, which we can mediate. So you can like choose how much we put of it.
Okay, let's back down for a little bit. So, what do you mean by these hyperbolic tangents?
It's just our activation function.
So that is what activates this particular node, let's say.
Yeah.
Okay, and these are like separate instances of conversations, right? On the parallel.
No, this whole thing is a conversation.
Okay.
These would all be like different questions.
Different questions. Okay.
So every time something is done, and it doesn't have to be the actual question text.
Okay.
I was going to say this later, but if this gets very large, it might be cumbersome. So there are ways to like cut out the noise from sentences.
Mhm.
Like, if I say like the really big cat, and then I never mention anything else that's really big or anything relating to size ever again, really big is not that important. So maybe I might be able to parse through like the sentence and remove stuff. So I might be able to like cut down data and make it more manageable for the future. Like there's some stuff that Stanford NLP made, so
Okay.
we can use that to try and make this like less cumbersome. But the whole idea here is this is just an activation function. It could also
Right.
be a sigmoid or something if you
Right.
wanted.
Okay.
And basically the idea here is that you can mediate an absolute amount to be taken from the very back and just taken forward. And it's very important because this basically means that we can actually like remember with enough weight historical data, which would otherwise be basically forgotten
Right. So
in the activation.
let's
process.
bring our viewers to like example use case level.
Yeah.
So let's give an example of like Archie, right? Our data scientist
Yeah.
dude, talks to you about data, right? So in a sense, it has the master context that it knows we're talking about the website, right? So that's already given. There's no bonuses for that. Now, let's say I start talking, for example, I want to give it a demo.
Sure.
Okay, Google, get me Archie Voice.
Okay, let's get the test version of Archie Voice.
What?
Archie here. I am ready.
What was my traffic in the last 24 hours?
In the last 24 hours, your traffic was 609, down 1.62% from the previous day. Anything else I can help you with?
What was my traffic in the last 30 days?
In the last 30 days, your traffic was 7,192, up 18.76% from the previous month. Anything?
Now, here you see, like, I have to do the whole question again. So, how would this, so if I said, instead of saying that, first I said, what was my traffic in the last 24 hours? And after the reply, I said, what about last 30 days?
Yeah.
How would that work out in this
So
framework?
basically here you're going to be remembering the data from the last 30 days.
Okay.
So then basically when you're passing in the new input, and you say what about the last 30 days, it's also taking into account this information. So it's basically using them both to get to an output, and because we'll train it, it'll basically start fitting itself to the function, and it will figure out that I use this information from here and a little bit of this, and I figure out, okay, 30 days from here, traffic from here, I
Okay.
put it together, right? Because if
Right.
you go down to a slightly more detailed image, we had I'll use two
Okay.
this time. We had our inputs and outputs, but we
Right.
also had previous layers, which were also mapped into here.
Mapped in here.
So it's additive.
So that's great. So now let me ask you this: what is the learning part of it? So can there be, like, for example, by definition, by familiarity, you might know I talk about history, right?
Yeah.
So you come in. What is that? How does that fall in? So for example, like me and you, because of familiarity, we might have excuse me, certain things that I love history, and when you walk in, or I love sports. So when I say what's the score first thing in the morning,
Yeah.
it's not because of location, it's not because of the context, it's because of familiarity. So how does that whole thing come in, that that I love basketball, and when I ask about score, it's score? How does it...
So this is more of a solution for things that are mentioned throughout the conversation,
Right.
but we could adapt it. We could add information about the actual person,
Right.
and then we can add that to the whole system. So that's a possible approach we could take
Right.
to implement what you're saying. There are many ways of doing it. I thought of this more as just within the context of our
Right.
current conversation.
So could you just quickly, for those who are just joining right now, go over the three solutions that we discussed today?
Okay.
So
So we've been discussing how to implement conversation. So this basically means, how do we actually remember context and figure out how to give the right answers to the right questions that are pertaining to context. So if I ask, say, what was my traffic in the last 7 days, and Archie tells it to me, and then I might ask them again, what was it in the last 30 days? It should remember that I'm referring to traffic. Currently, we're just using a classifier at each step and nothing else, so it forgets completely, but we need a way to store it and figure out which is the germane data. So we had 3 solutions. So one very naive solution is basically to use a classifier that will try and figure out if we're looking for context, and if it figures out that we're looking for context, it might automatically get that from 1 or 2 conversations back. That's a very naive and flimsy way to do this, but it would be very quick to implement.
It might be effective.
It might be. A much better way to do this would be to use the conversation tree, or multiple conversation trees. It's very good if we know what the conversation is about, and it's helpful because we don't need to train it too much. It's not great because it's not flexible, so we basically, and it's a little bit tedious because we have to build it ourselves. It's good for us specifically because we already have some of the architecture for that built behind the scenes, so we can use that. But a much more scalable solution, as long as we could get enough data to train it properly, would be to use a long short-term network. So it's
a long
short-term memory network.
Memory network.
So it's basically a better version of a recurrent neural network. So in a recurrent neural network, you can see here you have 2 cells. So imagine this is the current net. Here you have
current
your input,
conversation. Yeah.
and you have your output.
Yeah. Current conversation.
And you have your hidden layers.
Yeah.
But the thing is, you need to remember the data from before. So here you store the hidden layers from our previous, from the previous time we asked it something. So basically, we're storing the data, and we're passing it both into our activation function and through this straight line over here, which allows us to basically remember long-term dependencies better than we would for a regular recurrent neural network. Because for a regular recurrent net, since you're passing it only into the activation function, it's getting normalized all along the way, so it's losing a lot of weight. It's just kind of becoming nothing, so you kind of want to remember stuff from long ago.
Right.
Because if you start a conversation, often you might, for example, mention what you're talking about once, and then you'll just refer to it as it, or as them, or whatever, for a very long time.
Very long time.
And if you were to use a regular net, recurrent net, it might just forget what it was, and then it would just get confused. But for this, we can remember this much longer, much better.
Right.
Yeah.
That's great. So those were the 3 solutions
Yeah.
we talked about. I think that was. I think if the only thing you learned from this particular workshop is that how hard it is to actually make conversations is what you should take away from. And I want people to know that when people are using bots, they expect these conversations, which is really great because the consumer comes into a bot, and I know a lot of bot makers are watching this. When they use your bot, they immediately expect you to like, hey, you can have a conversation. Okay, what is your name? Okay, and they expect to have a conversation, and just the fact that you can have a really functional product, a bot who does a lot of things, that's really easy to do, but these conversations are very difficult. And if that is the only thing that you take away from today's workshop, then I think that would be worth it. However, we have a bunch of resources that we published in our blogs and stuff, but so far today, we will be back on Monday again. We will be back on Monday doing another show. We will be talking about this brilliant new device. What I want to say is that I want to talk a little bit about Google Assistant and Alexa, and the reason I think that these are the two technologies that are going to be very crucial. There are a couple of reasons. Number one, all this bot typing into it is something that is still cumbersome. But something like this, where you can actually, these conversations, and when you're building a bot, you understand that building and making it to work on a system like this is just an extension of what you already do. It becomes this enormous opportunity. So for example, right now, if you notice, if you have a Google action, you don't even, your end user doesn't even have to install an app. So you understand, you can actually talk to your Google Assistant right now and have certain functions, and there's only 400 of them, actions. You can actually install a bot by asking Google Assistant, hey, for example, Archie.AI, we're launching, hopefully within this week for our Google Assistant product, and we're going to have a separate show for that. You wouldn't have to download anything. All you'd have to do is you'd have to turn on, or if you have a device like this, okay Google, get me Archie Voice.
All right, getting the test version of Archie Voice.
Archie here. I am ready.
Archie, what was my traffic in the last 24 hours?
In the last 24 hours, your traffic was 609, down 1.62% from the previous day. Anything else I can help you with?
Yeah. Where did I get most of my traffic in the last...
Hello. What else do you need?
Where did I get most of my traffic in the last 30 days?
In the last 30 days, your top traffic source was CanadaSafetyCouncil.org at 58.35%, followed by Direct at 28.23% and OSG.ca at 5.06%. Anything else I can help you with?
Archie, when do I get most of my traffic in the last 7 days?
If you want to increase your traffic, I recommend you focus resources on driving traffic.
So as you can see that, this is an individual. Almost the experience, the experience that limits it makes it also more human. So for example, the home device cannot show me charts, but the fact that it can deliver this particular data point or whatever I'm looking for in on demand, just like a human would, is essentially helping us create this. And I see all these bots people are creating to slowly move on to something like this, where it actually saves you clicks. And I see a lot of bots, and this is kind of my pet peeve, I see a lot of bots that are like booking plane tickets and things like that. Now, I like you want to book a plane ticket through messaging. It sounds great if there is a reinforcement learning loop and that ensures that the bot is actually doing a processing that actually gives me a better prices. Otherwise, it's just a cumbersome process. Do you know what I mean? So for example, I could go to Momondo.com and see it suggests me and all that. If the same functionality you give me with a bot, that's actually not that great. Do you know what I mean?
Yeah.
If you're going to give me a bot, it either has to have a significantly better capability or the experience has to be better. The experience is different, not necessarily better, right? So something like this comes in very handy. So anyways, thank you for your time today. We will on Monday we'll be back with you from our headquarters and around the same time. But thank you for those who joined us today. From here, from San Francisco, I'm Ishtiaq, Adriano.
Yeah.
Bye.
Thank you.